You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axle-ends. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axle-ends. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
All right, well, welcome to another episode, Behind the Wheels. I'm Mike Yeagley.
I'm Dave Walters.
And I'm Doug Mason.
Well, the first episode, we talked about wheel-offs and how, when a hub no longer can hold the wheel. Now, we're going to go to another component of things not holding together, and we're going to go with what happens when a wheel can't hold the tire. So, Doug, you want to talk a little bit about what's going on there?
Yeah, just some very simple things at first to get into, and I'm sure many are aware of this, but obviously there's many different tire sizes, there's many different rim sizes or wheel sizes, and there is a rhyme and reason to how these are all put together. They're very engineered components, as you can imagine, with the load they have to hold, and again, we talked about the last episode, the amount of tension that you use and the force you use to hold a wheel on. But in this case, there's a system, and it's in North America, it's the Tire and Rim Association, and other areas, there's the European version, ETRTO, and there's also JATMA over in Asia. And these organizations have put together standards that will show specifically a wheel size and what tires can fit on this wheel size. So if you have a 22.5 by 8.25, there are certain tires that can fit on this. And there's many different sizes, actually, that can actually fit on that 8.25 inch rim, but only so many can go on there. If you try to put the wrong ones on, you can have a very bad situation, whether it's a too small or too large situation. And so that's just maybe a very general initial thing to understand, that this is an engineered component that goes together, and there is rhyme and reason to how it works. But there are other situations.
Well, one thing that I think is real important here is, as we're talking about these components, the wheel and the tire going together, when somebody's looking at that wheel, they're thinking, I'm going to ask you to picture a wheel without a tire on it. And what you've got is you've got the rim. It has a high point. It comes down straight. We call that the rim flange. And then it goes down at an angle and then goes into what we call the drop well. It sort of dips down into a little well type thing. And then it comes back up at an angle, and then you have the other rim flange. So you have the two rim flanges on both ends of that. And people think that rim flange is what's holding this whole thing together. And, well...
Yeah, that's not the case. The tire is designed to sit on what we call the bead. And there's a couple different bead angles. You can have flat base, you can have 15 degree, and you can also have a 5 degree, which is really primarily past car and light truck. We're talking heavy truck industry here, and for the most part, you're talking a 15 degree bead angle, and the tires are designed, the steel beading and everything that's in them, to sit and adhere on that bead seat. The flange really doesn't hold the tire in place.
Not when you have an angle there.
Right.
If you have the angle, then it's not the flange that's holding it together. It's that angle, that machined angle that holds the whole thing together. What we've done is we've actually taken a wheel, we've machined down that rim flange just to see how low and it will still hold together. Mm-hmm. It's we don't do that. Don't do that at home. No. It holds together though, and because what's really holding the whole thing together is that in a heavy truck application, and we mostly talk about heavy truck applications on this podcast, it's going to be that 15 degree bead seat is what we call it.
And I can add in, there are, back in the days of cast spoke wheels, they used to call them flat bases. And the flat bases, they actually seated on the rim area.
On the rim flange.
They actually, there was a bigger flange. But those flat base had tube types, and it was a different world. And when I always tell somebody in the field that the tire actually seats up on the 15-degree taper, I tell them the rim flanges are put in there for engineering support, and they're put in there for safety. And so, you know, there's a reason for everything that we do. But when you explain to somebody, the tire actually seats on that 15-degree taper. So when you're lubing up the tire and the wheel, it's so important to lube the tire, lube the wheel so they come out and seat up in the right spot.
And when you say lube the wheel, you're talking about specifically lubing on that 15-degree taper.
Well, yeah, you put lube in there so that tire can slide up there and seat in the proper spot. If it doesn't, there's what we call concentric seating, and that's a whole nother show and topic. But
things get complicated.
those are copied. But what I want to really ask Doug now, the most famous one that I ever heard of and the whole world's heard about the 16 and the 16 and a half. Can you tell us what happened in that case?
Well, I mean, as you can see, they're so close in size, right? You've got a 16 and a half and a 16 together.
This is the diameter of the wheel from bead seat to bead seat. So if you take the wheel and you measure it across the diameter of the wheel, where that tire mounts, where that tire seats, that's going to be either 16 inches or 16 and a half inches in these two different geometries you're talking about.
And there was a lot of confusion about what tires could go on which one. And when you put the wrong tire on, you could literally blow it off. And the force when you air up a wheel is significant. I mean, it's dangerous, very dangerous. There were, unfortunately, some situations that were very serious. We'll just leave it at that at this point. And that brought about an understanding that there has to be more clarity around the wheel sizes and the tire sizes that go together, and that was a big learning experience.
One of the things I hear about are people buying heavy truck wheels, and the heavy truck wheels tend to be in the half-inch increments. So you're going to have, when I say increments, it's going to be 1-inch increments, but it's going to be at the half-inch marks. So it's 19 and a half inch, 17 and a half inch, 22 and a half inch. It's these half-inch markings that is the heavy truck applications typically. And those are going to be typically the 15-degree bead seat that we're talking about, that 15-degree taper. Automotive applications are going to be in the
and light truck.
And light truck are going to be like 20 inches, dubs, 22s, 16 inch, and so forth. And those are going to tend to be 5-degree taper on those. Completely different engineering concepts go into each one of those, and really they're intended for different applications. And so you brought up the 16-inch versus the 16 and a half inch.
Correct.
And so these are two completely different engineered products, but they look identical or really close.
Close enough, that's the problem, right?
And we run into the same problem today. Every so often we'll run into somebody who grabs a heavy truck wheel, thinks, I want a heavy truck wheel, machine it up, put it on my SUV, get that nice bling, and it's really going to look great. And regardless of how it looks, you've got a 22 and a half inch wheel, and then there's a risk they're going to, or 19 and a half inch wheel. Let's say they put a 19 and a half inch wheel on there, and then they put a 20-inch tire. That's not how it's designed. That's not how that's supposed to go together. And you're going to have all sorts of problems.
Yeah, so I guess just to summarize, it's very simple, quite honestly. There's a list put out by Tire and Rim Association. Most tire shops very clearly abide by this. If you go in and I say I have this size wheel, they're going to put the proper size tire on it per the specifications. Same thing in the trucking industry, of course. But there are other reasons why a tire might come off a wheel.
Absolutely. And the one that I'll really talk about is in the industry, we call it small wheel. And it's basically when there's a tire fire, a brake-related incident, something happens on that truck, and the heat basically will heat up and shrink the part of the wheel. What happens is a tire can take about 290 degrees before it starts to get pliable. So normally the tire goes first, but you got to understand that heat goes from, the brake drums or from something through the wheels into the tire. So if the tire is at 290, and melts away. On the wheel, what kind of heat went through that? So Alcoa, we did something really fantastic. We actually put two heat sensors on the wheel, one at the end of the roll stamp and one in the middle of the wheel. And these will turn colors. Like brown will tell you there's some heat going through it, but when they become black, you know that too much heat went through that wheel, and you should remove that wheel from service. So, small wheels is a big safety issue because if you try to remount a tire on a small wheel, it's going to come off. So, and that's when bad things can happen if you don't follow OSHA regulations. OSHA regulations are twofold. One is, put the tire and wheel in a safety cage, or it has to be actually, the wheel has to be, bolted to the truck. Those are the only two ways that you technically can inflate it. Then OSHA regulations is you have to have a clip-on chuck and stand out of the trajectory when you air them up. And people will say, well, I can't seat the beads in a tire cage. I can't seat the beads. You can actually, according to OSHA, seat the beads with a bead blaster or something. Anything that you can use that doesn't take more than 5 psi. So you got to seat the beads, then you can put it in a tire cage or put it on the truck. But it has to be restrained because if it is a small wheel and you don't know that, these are critical.
So I want to take a couple minutes here and talk a little bit and try to describe to you. We can't show you a picture, but I'm going to try to describe what a small wheel is. I'm going to ask you to take a moment and picture the wheel on your automotive, on your front axle of your car. And what you've got is the disc side, which is mounted right there. That's with the nuts on it and everything. And then cantilevered inboard of that is the rim, and that open side of the rim is what gets small. So what happens is when you heat up, when you have like a tire fire or you have a brake fire or something like that happens, what it does is it anneals the metal. So especially this happens with aluminum wheels, and that metal will get annealed. And what that means is that it loses its shape. It loses its ability to hold its shape. And what happens is that open side, the pressures of the tire and or if you're driving on it, if you're driving after a break, after it's annealed, whatever, if the tire blows out and you're driving on the wheel, what'll happen is that open side is going to get smaller. So now the wheel is sort of it's the normal size at the closed end, at the disc side, but it's smaller on the open side. So what happened, let's say you put a tire on that looks okay. You can't tell the difference. You put a tire on that, you air it up, and what happens is that it lets go on that open side, and all that force pushes the wheel and pushes it airborne. It's like a slingshot, and it shoots out, and it is enough energy to throw a 150-pound man 100 feet into the air. It will. And I'm not, this is not hyperbole, this is not joking, this is not exaggeration. It can kill you. It kills people occasionally. And we do everything we can to keep people alive by telling them about the dangers of having that small wheel event.
And just to maybe make it a little more visual, you got to think about it as a diameter. And so that diameter of the open end was, say, 20 inches. And now, by heating up the material, it's lost its strength and no longer can retain that same size. And under the pressure of the tire creates the diameter to shrink. And we were talking about that 15-degree angle. Well, now that angle is dropping from where it's seated previously. And again, like we said, the wheel is held in position by that bead seat, not the flange, and that's why it looks like the wheel's okay.
Yeah, look, you see the flange.
Yeah,
the
looks
flange
okay.
is there. It looks okay.
But it's not. Now, at that point, then you lose the air out of the wheel and create the situation you talked about. But there are a number of ways which are very important to ensure that if a wheel, you even think a wheel, has gone through a heat event or has been driven on that you can check. And Dave, I think you have some real clear descriptions of this.
Yeah, I mean, years ago at TMC, we wrote on RP, and an RP is a recommended practice for the industry. And basically, we're saying, look, when the wheel gets smaller, there are signs actually, like it could be burnt looking, it could be charred. But so we said, we got to do better. So we created 3 ways of checking this. The first way is the best way, as we always put it, and that's buying a TRA tape from Tire and Rim Association tape. And this tape is, you can buy a 22.5 or a 24.5, or you can buy a 17.5. They are by far the best method to do this. Unfortunately, the tapes are a little pricey, and
you may never use them.
And the industry doesn't buy them. And so then we went to the second method, to buy a carpenter square. And you can lay that carpenter square on the face of the wheel, run it across the 2 rim flange areas of the wheel. And if you, on the open end, because this never really happens on the disc end, it's always on the open end, if you can put 30 thousandths or a thickness of a driver's license or credit card underneath it, then you might have too much issues and you need to take that wheel out of service. The third one is simply a roll test. So if you have a flat area that's about 10 feet long, you can roll that wheel. And if that wheel turns towards the open end of the wheel, the chances of that wheel being small is good. So, I mean, there are practical ways of checking these wheels to see if they, got heat through them. Like I said, we put actually stickers on our wheels, and at 405 or 400 degrees for 5 minutes, they will turn black. And so we know that. So, I mean, we try to live safety. But what I always tell everybody, if you put that tire wheel in a safety cage when you're airing it up, that's the most safety thing you can do, because you don't know what may have happened. You don't know when you get a zipper rupture out of the tire. You don't so that's critical. But when you get a small wheel, there's ways to check for them. Make sure that you take proper care and then mount them in a cage or restrained on the vehicle.
Mm-hmm. And so I guess, again, the indications would be obviously the sticker on maybe an Alcoa wheel or and any other wheel. You're going to see evidence of heat. You're going to see a charring of a sticker or of a label or even some tire residue on there. And in any of those situations, you need to check and make sure that nothing has happened to the wheel.
When I do training classes, people will always say, well, when should I check a wheel for being small? And my comment is, once one has been into service, I would check it before I put it back on that tire. And a carpenter square, and it's funny because the people will say, it's that simple. It's that simple. And you go around 4 different spots on the wheel and you make sure it's still round. Carpenter square costs you like $6-7. So for $6-7, you got a tool that basically you can use, and anybody can use that, and everybody has a driver's license or a credit card. Some people might not have 30,000 feeler gauges, so we tried to make it simple.
Let's hope they have a driver's license.
We hope.
Okay, well that about does it. We covered that wheels and tires. You need to make sure that they're always going together properly. You don't want to put a 16.5-inch wheel with a 16-inch tire or anything like that. And to make sure, and one of the things we did not mention is that on those tires, it says on them that it's whether it's a 16 or a 16.5 or 22 or 22.5, it'll say on the tire and it will say on the wheel. It'll be marked right on the wheel if it's a 22.5 or whatever that diameter is. And so that's real important when you're trying to evaluate the safety of putting that wheel with that tire. A couple other things is that you want to make sure you're mounting right on that taper. You need to remember that it's that taper that's holding everything together. So you want to lube everything up real good. that lube the tire, lube the wheel on that taper, and make sure that's all mounted up real nice. If you have any suspicion of an event, of a heat event, look for that indicator on the Alcoa wheels at least. That indicator will be right next to the roll stamp, and it'll be in the top of the drop wall, in the middle of the drop wall on the tire side. And that indicator, if it turns charcoal black, then you really need to check it. And honestly, like Dave said, you probably want to check that every time anyway. When you're checking it, the way you check this sort of thing is you use if you're really going all out, you can use the TNRA gauge that it's available. You can go to the the Tire and Rim Association website and buy one, or you can use the carpenter square. And the carpenter square goes up, like Dave mentioned, it goes up on the disc face of the wheel, and then the other end of the other leg of the carpenter square goes from the rim flange to the rim flange. And if you can get a credit card into that open end side, it's time to take that wheel out of service. And then the last way to check it is if you don't have the carpenter square, if you don't have the TNRA rim gauge, take the wheel, get a nice flat surface about 10 feet, and roll it. And if you see it roll off and it rolls off to the side, then you most likely have a small wheel there. When you're putting a wheel when you're inflating a wheel, a tire on a wheel, you want to make sure you use that inflation cage. Every tire shop I've been to in North America, and even the tire shops I've been to around the world, have those. So use those inflation cages. That will make sure that everything's okay if there is something that goes wrong. Finally, if you don't have access to an inflation cage, put the wheel onto a vehicle, mount it up, and then air it. And that's going to hold that wheel in place. And get away. Use a clip-on chuck, walk away, have some length of inflation hose between you and that wheel. I'd say 10 feet or more.
10 feet.
And
stay out of the trajectory.
Stay out of stay off to the side, air it up, and just stay, like Doug mentioned, you need to stay out of that trajectory. That's a lot we covered in a relatively short show, but I think that does it. Thank you for joining us on this episode of Behind the Wheels. If you'd like to contact us with any questions, comments, or suggestions for future episodes, you can write us at alcoawheels@arconic.com. See you next time.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.